Hello guys, welcome back to our channel. Today we are going to learn about inverse function. What is inverse function? Now let's look at this picture. There are two factories. Factory A produces newspaper from a paper. Meanwhile, Factory B recycles the newspaper back to paper. Now you can imagine that Factory A serves as the function. Meanwhile, Factory B serves as its inverse function. So in conclusion, inverse function is a function that reverses another function in which the output returns to its original value. Now let's look at these two relations. Set A is mapped to set B by a one-to-one relation. Meanwhile, set C is mapped to set D by a many-to-one relation. If you still remember, these two relations are considered function, as every object produces only one image. If we reverse one-to-one relation, we will still get a one-to-one relation. However, if we reverse a many-to-one relation, we will get a one-to-many relation, which is not a function. So in conclusion, only one-to-one function has an inverse function. Now you need to determine whether the following graph has an inverse function. Since we have known that only one-to-one function has an inverse function, therefore we can use horizontal line test to determine whether the following graph has an inverse function. Look at this example. Notice the horizontal line intersects at only one point on this graph. Therefore, this graph has an inverse function. Now let's try on this graph. In mathematics, inverse function can be written in this way. If you look closely in this arrow diagram, y is mapped to x by the function f, and therefore, the inverse function of f will map x back to y. So in conclusion, the domain of the function will be the range of its inverse function. Meanwhile, the range of the function will be the domain of its inverse function. Now let's look at the first example. You are given function f of x equals to 2x plus 3. Question A. Find the inverse function of f. And question B. Find f inverse of 5. To find the inverse function of f, just remember to follow this simple step. First, you must let f inverse of x equals to y. Therefore, f of y equals to x. Substitute y into the function f of x and you will get 2y plus 3 equals to x. Therefore, you get y equals to x minus 3 divided by 2. Remember to rewrite your answer as f inverse of x equals to x minus 3 divided by 2. Question B. To find f inverse of 5, just substitute 5 into the inverse function of f and you get the answer 1. Now let's look at the second example. You are given f of x equals to 3 plus 5x. Find f inverse of 13. To answer this question, just follow the same step. You must let f inverse of 13 equals to y, and therefore f of y equals to 13. Substitute y into the function f of x and you will get 3 plus 5y equals to 13. And finally you get your answer y equals to 2. And remember to write your final answer as f inverse of 13 equals to 2. Alternatively, you can find f inverse of x and then substitute 13 into the inverse function and you will still get the same answer 2. Now let's look at the third example. You are given f inverse of x equals to 1 minus 2x divided by x minus 1, where x is not equals to 1. Find f of x. So in this question, you are given the inverse function of f and you are trying to find f of x. We can still use the same method. Let f of x equals to y. F inverse of y equals to x. Substitute y into the inverse function of f. 1 minus 2y divided by y minus 1 equals to x. Rearrange your equation so that you get your final answer y equals to x plus 1 divided by x plus 2. And remember to write your final answer as f of x equals to x plus 1 divided by x plus 2. Now let's look at the fourth example. You are given function f of x equals to 5 minus 3x. Question A. Find f inverse of x. To answer question A, just follow the same step. Let f inverse of x equals to y. F of y equals to x. Substitute y into the function f of x. 5 minus 3y equals to x. So your y equals to 5 minus x divided by 3. Remember to write your final answer as f inverse of x equals to 5 minus x divided by 3. Question B. F inverse of f of x equals to f inverse of 5 minus 3x. So substitute 5 minus 3x into the inverse function of f and you should get your final answer x. Question C. F of f inverse of x equals to f of 5 minus x divided by 3. So substitute 5 minus x divided by 3 into the function f of x and you should get the final answer x. From this example, we can conclude that when we compose the function with its own inverse function, no matter which function comes first, we will still get the answer x. Therefore, we can use this test to verify whether these two functions are inverses to each other. Now let's look at the fifth example. Show that for every value of p, the function f of x equals to p plus 1 divided by x minus p is its own inverse. When the function f of x is its own inverse, it means f of x equals to f inverse of x. To find the inverse function of f, we let f inverse of x equals to y, f of y equals to x. Substitute y into the function f of x. P plus 1 divided by y minus p equals to x. Expand this equation. And remember, your aim is to find y. So, arrange this equation so that y will be on one side. Px minus p squared plus 1 equals to xy minus py. Look at the function f of x. We have the denominator x minus p. So, take out x minus p from this equation. You get p multiplied by x minus p plus 1 equals to y multiply x minus p. And you should get the final answer, f inverse of x equals to p plus 1 divided by x minus p, and therefore f of x equals to f inverse of x. Now let's try this question. If you are asked to sketch a graph of an inverse function, all you need to do is just remember one simple fact. The graph of a function and its inverse are reflected over the line y equals to x. Notice the x and y coordinates of the inverse function are switched. Now let's try to sketch the inverse function for the following graph. That's all for today. Thank you for watching. I'll see you in the next video. Bye.